Well, now we're doing question 31 on section 1.6, and we have to find the domain and range of f and f inverse. We also have to find f inverse and show that the composite of f inverse and the composite of f inverse of f of x both equal x. So let's start with the domain of the function. And the domain of this is all reals but 2, because 2 would take that to 0. So x is not equal to 2. Consequently, we know then that the range of the inverse function is going to be all reals but 2. So y is not equal to 2. And the range, well, let's see, the horizontal asymptote is going to be the quotient of x over x is 1, and these additional values, constants, are insignificant. So that's going to be the horizontal asymptote, so y, the range is y is not equal to 1. So the domain of the inverse function is all reals but 1. Now we have to go ahead and find the inverse function. So there's our function. Our first step is to write this in terms of y equals x plus 3 over x minus 2, and then exchange x and y's. So we get x equals y plus 3 over y minus 2. Now we need to isolate, we need to get rid of these denominators. So we'll multiply both sides by the common denominator, which is y minus 2 and y minus 2. Now on this side those divide out, and when we multiply this out we get xy minus 2x equals y plus 3. Now we'll get all the y terms on one side, everything else on the other. So I've got xy, and subtracting y from both sides, and adding 2x to both sides. Here's what we arrive at. Now let's factor a y out of each of these terms, and we get x minus 1 as a factor on y equals 2x plus 3. Now isolate y, and we get y equals 2x plus 3 over x minus 1. And now we'll claim that f inverse of x equals 2x plus 3 over x minus 1. And notice the domain of this is all reals but 1. That's what we have here. And the horizontal asymptote is going to be the quotient of 2x over x, which is 2, and so the range is all reals but 2, and that's what we have here. Good. So now our next issue is to verify that this is actually the inverse of the given function. So we'll evaluate f of f inverse of x, and if we get an x back, then clearly it's we've chosen the right inverse function. So the composite of these is going to be, so this is f, so I'll replace every x with f inverse of x, but f inverse of x is 2x plus 3 over x minus 1. 2x plus 3 over x minus 1 and plus 3. And let's see, 2x plus 3 over x minus 1, and we've got a minus 2. So all we did was replace each x with f inverse of x. Now we need to get rid of these common denominators of x minus 1. So let's multiply by 1 in the form of x minus 1 over x minus 1. And this equals, when you distribute this x minus 1, when you multiply this term by that, the x minus 1's divide out, and you just get 2x plus 3. Plus 3 times, and multiplying this 3 times x minus 1, you get an x minus 1 here. Now by the same argument, if you multiply x minus 1 times this term, the x minus 1's divide out, and you get 2x plus 3, and minus 1, and then minus 2 times x minus 1, and that's minus 2 times x minus 1. So let's simplify this, and we get 2x plus 3 plus 3x minus 3 all over 2x plus 3 minus 2x plus 2. And now the 3's add out, the 2x's add out, and we're left with 2x plus 3x is 5x over, and 2 plus 3 is 5, and those divide out, so this thing equals x. So therefore we chose the, we found the inverse. This is correct. Now, I challenge you to find the composite of f inverse of f, and make sure you also get x. So you're going to find the composite of f inverse of f of x, and verify that you do get an x back. Now we're on 1.6 doing question 43, and there's 3 parts, A, B, and C. And we know that this is a composite function of f and f inverse, where f of x would equal e to the x, and f inverse of x could equal ln of x, or vice versa. So then this simply equals 7.2. So for B, we're given that e to the negative ln of x squared, and we've got to simplify that. So that equals e to the ln of x squared to the negative 1, which equals, by the law of logs, e to the ln of 1 over x squared, which equals 1 over x squared. And finally, C, we have e to the ln of x minus ln of y, and by the law of logs, that equals e to the ln of x over y, which equals x over y, and we're done. So for question 49, we have to solve for y. So let's see, we'll let each of these be exponents on e. So we have e to the ln of y minus 40 equals e to the 5t. And this is a composite function of a function and its inverse, so we get back y minus 40 equals e to the 5t. So isolating y, which is our task, is going to equal e to the 5t plus 40. We had to isolate y, and we just did it. We're done.